Okay, that's position we're going to be talking about. Position is definitely. What's another word? Distance? You guys don't know what distance is? Come on, guys. Come on. Displacement might be new. You might have heard of it before. Come on. Seriously. Come on. Okay. Speed. Speed. If you were in a car, every car has something called an odometer, which measures your speed at that moment, right? So if you look down and it says 40, that is your speed. Not only your speed, but it's your instantaneous rate of change. It's the same thing. Okay. Now, what's the difference between, or what is speed? Let's put it that way. What is speed? We said velocity is distance I traveled divided by how long it took me to get there. So what is speed? What's the difference between speed, right? People like cars that go fast. People like cars that have high speeds. What is speed? No one likes cars that go, everyone likes cars that go really, really slow. I don't, I like cars that go fast. What is speed? Exactly. Miles per hour is speed, right? Speed, miles per hour. So let's look at miles per hour. Miles per hour is miles for every hour, right? Miles traveled for every hour. That kind of sounds familiar. What does that sound like? Kind of like slope, something we just did like 2 minutes ago. It looks like velocity, right? Isn't it? Isn't miles how far I traveled, right? Divided by a time, hour, right? So can I measure speed in this? Can I say, okay, so it's about 15 feet from where I'm at right now to my desk. Okay. So I travel there. Took me about 3 seconds. Okay. So 15 feet divided by 3 seconds is 5 feet per second. Right? That's my speed. What's the difference between speed and velocity? It's written on both pages, actually. Actually, just the first one. What does that mean? There you go. Speed's always positive. Speed's always positive, right? So velocity, that means velocity has to be negative or could be negative, right? And that's the difference between them. Speed and velocity are exactly the same thing. The difference is speed's always positive. On your car, on your odometer, if you have a car, you see this every day. If you don't have a car, you ride in a car, you see the odometer, right? Is it ever negative? So I'm getting out of so I parked my car in my garage. To get out of my garage, I got to back up. I back up, turn onto the street, and then I go. So when I was backing up, what is the odometer? Does the odometer say negative miles an hour? Why not? I'm going backwards because it's speed. It's measuring speed. It's always positive. Speed's always positive, right? If you're going backwards, it doesn't matter which direction you're going. Sideways, forwards, backwards, doesn't matter. Speed's always going to be positive. Okay? So speed and velocity are the same thing. Just if it's a negative number, make it positive. That's speed. Okay? So how can velocity be negative? We're going to talk about that today. That's what we're going to talk about today. Okay? It's actually on here. So this is the big thing for today. This is another big thing. This is on these first two slides is going to, today is either going to be really easy or really hard. It's going to be really easy if you actually read all of this stuff and follow it. If you follow it and read it, it's going to be really easy. Today's is really easy. But if you don't, and you're kind of just like, oh yeah, I get it. Let's go on to the problems. You're going to be in a world of hurt because it's all there. Okay. So position is where you're at right now. Where I'm at right now. You're sitting in your desk. I'm standing right here. That's position. That's where you are at, right? My position is here now. Now my position is here, right? That's position, where you're at. Okay. The derivative of position is velocity. We talked about what velocity is, right? Distance over time. Okay. So there's two ways you can note this: the derivative of position or velocity. Okay. Sometimes they say v of t, sometimes they say x prime of t. It's the same thing. Okay. The derivative of velocity is acceleration. What's acceleration? In your car, you have an accelerator. What's that? There you go. The gas pedal, right? My car doesn't have a gas pedal. I call it an accelerator because my car is not gas. My car is electric. But most of the time, it's called the gas pedal, right? So it's called the accelerator because the harder you push on it, what happens to your car? It accelerates, right? It accelerates. Well, if I'm going 60, let's say I'm going on the highway. I'm going 100 miles an hour on the highway. Don't do this, but let's say I'm going 100 miles an hour on the highway. What's my acceleration? Riley, what is it? Yeah, you're doing it with your hand. Yeah. 0. Yeah. But I'm going really, really fast. How can I have an acceleration of 0? Exactly. I'm not going up or down, right? I'm not going up or down. Where on the highway do you have the highest acceleration? Exactly. Exactly. When you're going off of a street where it's 40 miles an hour onto the highway where sometimes it's 70 miles an hour, you got to catch up, right? You don't want to get hit by a car, so you have to speed up to try to match the speed of what's going on there. You're picking up speed. So when you're picking up speed, that's acceleration. Okay? So some people think, oh, that's going fast. Not necessarily. I could be going 500 miles an hour. But if I'm staying at 500 miles an hour, there's no acceleration, right? What if there's an accident coming up, I got to slow down? What happens to my acceleration? It becomes what? Negative. Yeah, negative acceleration. That's what negative acceleration is. Slow me down. Okay? My velocity is still positive because I'm still moving, right? I'm still moving. I'm just going a lot slower, right? So acceleration. So acceleration's got 3 names. The first name is the second derivative of position, or the first derivative of velocity, or just acceleration. Okay, so these symbols here, you're going to see a lot. That's what they are. Okay, so it's just kind of a reference page. Like I said, reference pages are huge in this one. All right. Let's see, displacement. Displacement. We don't really talk about it in this lesson so much. We'll talk about it next semester. But displacement is how far you are from where you started. Okay, so I start here. I walk over here to the door, about 15 feet. Walk back over here. What's the distance I traveled? 30 feet, right? 15 and 15, right? That's distance. What is my displacement? 0. Yeah, 0. Because I'm back where I started, right? That's the difference between them. Okay. Displacement is how far you've actually, where are you from your original position? Where are you at now? Okay. Distance doesn't care. You could walk back and forth, back and forth, back and forth, back and forth. That's distance. I got to add all of those 15s up, right? Displacement, no. How far are you from where you originally started? Okay. When something is at rest, how do we know when something is at rest? Stopped. Velocity is going to be 0. Okay. When a particle changes direction, now we're talking about direction. Direction now. That's why sometimes velocity is going to be negative. When do I know when velocity or a particle has changed directions? Particle is an object that moves, right? I could be a particle, right? If I move. It's when velocity changes signs, okay? From positive to negative or negative to positive, right? And can't velocity be a derivative too? We've done that before, right? We just did a lesson like that yesterday, okay? Velocity is increasing when acceleration is positive and decreasing when acceleration is negative. Speed is increasing when acceleration and velocity have the same sign. They have the same sign, speed is increasing. Speed is decreasing when they have opposite signs, okay? Average acceleration of an object is the total change in velocity divided by the total change in time. It can be thought of as the slope of the line connecting 2 points on a velocity. So that's just pretty much saying it's the derivative of velocity, acceleration is, okay? This is a table of what I just said. All that stuff I said, it's just a table of it. Sometimes it's easier to look at a table because they're gonna ask you, when is the particle at rest? Tell me when the particle or the object is at rest. Well, doesn't at rest mean stopped? So all along here, right? When is that? When velocity is 0, right? Acceleration doesn't matter. We're talking about just velocity. Or it'll say, when is the object speeding up? Well, when velocity is positive and acceleration is positive. First derivative and second derivative are positive. Or first derivative and second derivative are negative. Okay? Right? Increasing, concave up. Decreasing, concave down. We've done all that stuff before, right? We're just using in terms of physics now. This is a physics. This is where math and science go together, okay? We used to have physics on this campus. We had a great physics teacher, but so a lot of students took physics. It was a great class because they built rockets. It was a fantastic class. A lot of calculus students loved it because it took calculus and it took science and it kind of bedded in, and who doesn't like building rockets, right? But our teacher, he was so good that he's actually teaching at college now. He's teaching at the college level now. So we haven't had physics on this campus so much, but it is a great class because you'll see a lot of calculus. If you know physics, calculus is a little easier. If you know calculus, physics is a little easier. So they kind of go together. Okay. So when am I going left and when am I going right? What does that mean? Because you're going to see, when does the object move left? When does the object move right? And what does left and right mean? Okay, so there's perhaps no more important type of rate of change than motion. Okay, Newton's laws of motion. Right is positive. So if I move to the right, if it says move to the right, that means positive, right? And if I move to the left, I'm going to move negative. So think of the number line, okay? So how do I tell? When velocity is negative, you're moving to the left. When velocity is nothing, 0, you're not moving at all. When you're moving to the right, velocity is positive, okay? So when it talks about moving to the right and moving to the left, that's what they're talking about, okay? Because this is all based off of the number line, okay? All right, so let's take a look at one. Let's take a look at the first one. You're going to see a lot of buzzwords. I would highlight, underline, circle, whatever you can, those buzzwords, because those are the ones that are going to be able to help you solve the problem. Okay? So example number 1. Particle or object. A particle is just an object. Okay? So it could be anything. It could be anything that's moving. A particle moves along the x-axis. That's the number line, right? The x-axis is the number line. Okay? So that time is always positive. Time always is positive. You can't have negative time, right? You can't. There's no way to have negative time. It's always going to be positive. its position is given by the equation, all right? Position is right here, okay? That's a buzzword right there, x of t, I know what that is. Determine the acceleration, all right? So another buzzword is acceleration when time is 7. So it doesn't tell us what time is. It could be hours, minutes, seconds. We don't know. Days. We don't know. We're not really caring about that. If they give us units, we're going to use them, but they don't give us units. Okay. So right now I have x of t. How do I find acceleration given position? How do I find acceleration when they've given me position? Second derivative, right? I'm going to need second derivative to find acceleration. So that's my first step. Second derivative. So let's find the first derivative. Okay, first derivative, 3t squared minus 22t minus 16. One more time. Uh, 6t minus 22. Second derivative is done. Now, what is t again? What is t for this question? T is time. And do they give us the time they want to do, they want us to find? 7, right? So anywhere I see a t, I'm going to plug in a 7. (42 minus 22 equals 20). Okay. There are no units. They don't give me units here, so just 20. It's not 20 hours, 20 days, 20 miles per hour, 20 whatever. It's not, they don't give us any units. If they did, we would label, but this one they didn't. Okay, so whatever that is, so that means at time 7, at time 7, you're accelerating by 20 whatever units it is. Okay, alrighty. All right, so example number 2, particle moves along the x-axis, positive, so that time is positive. All right, that sounds familiar. Position is given by here, so we got the position. What do we need to find? What are they asking us to find? When what is 0? When the particle is at rest, right? Particle is at rest, yeah. Okay. When the particle is at rest. So Roman's right, something's going to be 0. But let's go back up here and figure out what is going to be 0. So you can look, particle is at rest, velocity is 0. It's written right there. It's written in the table here. Stopped, right? Or it's written right here. Object is stopped. Either one of those will tell you the same answer. It's when this equals 0, right? Okay. So what do we have to do first? Exactly. We got to find velocity first, right? We got to find the velocity, which is the first derivative of position. So 3t squared plus 12t minus 36. That is also known as velocity. Okay. Now we got to set that equal to 0 when that is equal to 0, right? Well, that's a trinomial. It's got 3 terms. It's a quadratic. So the easiest way to solve it is by factoring. Okay, so let's see if we can factor this guy. Well, you can divide them all by 3. I see they can all be divided by 3. GCF, so I get 3 And then t squared plus 4t minus 12. So I got to find the two numbers that multiply to be negative 12 and add to be 4. Positive 6 and negative 2. Okay. I'm going to set those equal to 0. Find the zeros. Subtract 6 from both sides. I get t equals negative 6. Add 2 to both sides, and I get t equals positive 2. Okay, so let's go back to the question. I haven't answered the question yet. Determine all the values of t when the particle is at rest. What's my answer? Negative 6 and 2. So here we go. This is a perfect example. This is going to be a type of question you see on a multiple choice, right? So let me give you an example. This will be your responses. None. Which one do you think you're going to choose? So you're saying just this guy here? Yeah, why just this guy here? Yeah, time can't be negative, right? It says it up here. Time has to be positive. So negative 6 is what we call an extraneous solution. Doesn't mean we did it wrong. We did it right. There's nothing wrong with that answer. It's just in practical terms, doesn't work. Doesn't work. Okay, 2 is the only answer that we can use. At time 2 is when the particle is not moving. Okay. So great example of this is going to be a multiple choice question. These types of questions are hardly ever free response questions. They're always multiple choice questions. I would hate to see this. You guys do all of your work and you do everything perfect, and then you do one of these. You circle this guy here. And on the test, I can't give you any credit for that. Even though you did everything right, you did 90% of the question right? I can't give you any credit for that. So just be careful, reread the question. Don't overthink yourself, but just read the question. Okay, don't assume that you know what the question says. Okay. Okay, so here we go. Next one. When is the particle moving left or right? Okay, so again, let's highlight what we got. We got position is this guy here. So they're giving us position again. We have to determine if the particle is going left or right at 5. Is it going to the left or going to the right? Is the particle moving at left or right when time equals 5? How do I know that? How do I know if it's moving left or right? Start there. How am I going to know? Because that's going to be my first step. So how do I know if it's going to be moving left or right? Yep. Right. Yep. Left and right. All else fails, go back to this table. I would start here because this has all the information. This has, before you do any types of calculations, check here first. So if it's moving left, velocity has to be a negative number. If it's moving right, velocity has to be a positive number. So that's what we're going to check. We need to check to see at, what number is it saying? 5. At 5, is velocity going to give us a positive number or a negative number? We've done this before. It's called first derivative test, right? We've done this before. That's what you're going to do. So we got to find velocity first. Okay. So let's find the velocity, find the derivative. Okay. That's velocity. It's got two names, x prime or velocity, v of t or x prime of t. It's the same thing. All right. So now what I'm going to do is I'm going to find 5. At 5, I'm going to plug in 5 and see if it gives me a positive number or if it gives me a negative number. Negative 10 minus 8 is negative 18. It's a negative number. So let's go back to my table real quick. I got a negative number. So since I got a negative number at 5, it's going to have to be moving to the left. Object is moving to the left. So how would I write that? I would write it like this. Because v of 5 equals negative 18, object is moving to the left. Okay. Or you could say, instead of v of equals 18, you could just say is less than 0. You can say that too. That's the same thing because that's all we're looking for. We're not looking for a value. We're looking for positive or negative, like the first derivative test that you guys have done before. Okay. All right, let's see here. Okay, so position, they give us position. Okay. And they want me to determine all the intervals where speed is increasing. Speed is increasing. I want you to try this one on your own. Give it a shot. See what you can do. I'll give you a few minutes to do it. Velocity is the first derivative. So when first derivative is positive and second derivative are positive. Okay. And when first derivative velocity and second derivative are negative. So when they're both positive or they're both negative. Increasing, concave up. Decreasing, concave down. Those are the 2 times we're looking for it. Okay, you've done that before. When I use the words increasing, concave up, and decreasing, concave down, you did that before. You've done that before last chapter. Okay, we're just using a different set of terms because, like I said, this has more of a physics ring to it. Okay, but it's the same thing. Okay, so first thing we got to do is find the derivative. So find out when velocity is positive and when it's negative. Okay, so 4t to the third power minus 36t squared. That's the first derivative, right? So I'm going to do the first derivative test to find out when it's increasing and when it's decreasing, because I need both. I need to know when it's increasing and when it's decreasing, right? When velocity is positive and when velocity is negative, because that's the first derivative. Okay, so I'm going to set it equal to 0. It's a binomial, GCF. I can divide them both by 4t squared. That leaves t minus 9. Okay. Set those equal to 0. so over here I'm going to get 9. Over here I'm going to divide by 4 and take the square root. You just get 0. So is 0 okay? Because it's a greater than or equal to 0. So when t equals 0, what's another way of saying t equals 0? It's not necessarily not moving. It's not talking about whether it's going distant. It's talking about t0. What's another word? Initial time, initial start, right? The start, right? When I start my watch. That's when I hit the watch, and whenever I'm timing or something, that's time equals 0, right? All right. And that, all right. So let's do first derivative test. 0, 9. Well, I don't got to worry about anything less than 0 because those are negatives, and we know time can't be negative. Okay, so I'm just worried about between 0 and 9 and bigger than 9. So I'm going to pick a number and I'm going to plug it into the first derivative. Okay. So let's pick 1. You can pick any number between 0 and 9, but 1 might be easier. Let's see. So plug it into the first derivative. Okay. Again, we're just checking to see if it's a positive or negative. Is it increasing or decreasing? This is 4 minus 36, which is negative 32. So it's going to be a negative number. It's decreasing. Okay. Now let's check to see a number that's bigger than 9, 10. 4 times 10 cubed minus 36 times 10 squared. So we're just checking to see which one's bigger, which term is bigger. Well, 10 to the third power is 10 times 10 times 10, or 10 with 3 zeros. Was that 10,000? 10 times 10 is 10 times 10 is 100. 100 times 10 is 1,000, right? 1,000. So this is 4,000 minus 10 squared. 10 squared is 100. What's 100 times 36? 36 with 2 zeros. Both big numbers, but going to give us a positive answer, 400. Okay. Not ready to make any judgments yet, though. Not ready to make any judgments yet because I need to be able to tell when acceleration is positive or negative. So I know when it's increasing. It's increasing from 9 on, right? And I know when it's decreasing from 0 to 9. Okay. So now I got to do second derivative. Okay, so second derivative is going to be 12t squared minus 72t. Okay, set that equal to 0. Do the same thing. I'm going to factor 12. Does 12 go into 72? I don't believe so. It does 6 times. Yeah, you're right. 6 times. So 6t. So t minus 6. So set this equal to 0. Set that equal to 0. So I get t equals 6 and t equals 0. Okay. Do the second derivative test on here. 0, 6. Plug in 1 again, plug in any number bigger than 6. So x double prime of 1, 12, 1 squared minus 72 times 1. I get 12 minus 72, which equals a negative number. Okay. Pick a bigger number. 10 again. Okay, so when I plug in 10, 12 times 100 is 1200. Minus 72 times 100. 72 times 10 is just 72 with a 0. So that's going to be a positive number there. Okay. All right. Done with my calculations. Now I got to do some analysis to see where's where. Where are the intervals where it's increasing in concave up and decreasing in concave down? Okay. So the easiest way to do this is to have both number lines kind of visible, so you can kind of, what we're trying to do is trying to, like, if I could take this number line and put it right on top of that number line, and where the pluses are on top of each other and where the negatives are on top of each other, that'd be perfect. Okay. So from 0 to 6 it's negative, from 0 to 9 it's negative. So where are they both negative? 0 to 6. So 0 to 6, speeding up. 6 to infinity, positive. 9 to infinity, positive. So where are they both positive? 9 to infinity. Okay. So where would it be speeding up? From 0 to 6 or 9 to infinity. Okay. How is speed increasing if it's negative? Or sorry, how is speed increasing if it's negative? Yeah. Yeah. So it's just kind of like, if you're slowing down like this, you can accelerate negative, right? If you're slowing down, if you're picking, so this will kind of sound redundant. If you're slowing down faster, right? That's negative acceleration. Okay. So you're speeding up. You're technically speeding up. Okay. Let's see here. Give me a second. Wait, give me a second. Let me check my notes. I forgot something real quick. Give me 30 seconds and we'll be done. Let's see. Speed is increasing. Yep. Never mind. I told you. I wanted to remember if I did tell you, but I told you I had something earlier. So yeah. Okay. We're going to finish this. So we did the calculations part. The next part is the graphs. Okay. So the graphs, there's not going to be a lot of work. When we start doing the graphs, when we start looking at graphs, there's not going to be a lot of calculations. But again, unless we have our background knowledge, we're strong in that. That's why you have the first 2 pages. The first page of your notes is all that background info. Okay, we're strong in that. So it won't take all block tomorrow. So I'll give you some time tomorrow to start the assignment in class. Okay, so don't lose these. We will finish them tomorrow. Okay.